start a new chapter of class 9 CBSE science, that is the third chapter, atoms and molecules. We know that everything around us is made up of some material which the scientists have named it as matter. Matter exists in three states: solids, liquids and gases. But did you think of simplifying matter? What is the simplified form of matter? Yes, we are going to answer all these questions very nicely and very precisely in this chapter. So let us start. First, let us get a brief introduction about the chapter. Around 500 BC, Maharishi Kannad, an Indian philosopher, he postulated that if we go on dividing matter, then a time will come when matter cannot be further divided. And he named these particles which cannot be further divided, he named these indivisible particles as atoms. He named these indivisible particles actually as Parmanu. And he named matter as Padarth. Yes, what is Padarth? Around the same era, another Indian philosopher, Pakuda Katayama, he elaborated this doctrine and said that these Parmanu particles, they exist in combined form. What do I mean by this? They don't exist independently, or one Parmanu particle cannot exist. It can exist, but in rare cases or few cases. Normally, they exist in a combined form. They are always present in a combined form in the nature, in the environment. Then, another Greek philosophers in the same era, Democritus and Leucippus, they also realized the same thing. And Democritus and Leucippus, they named these particles, these Parmanu particles, as atoms. Firstly, Democritus only has given us the word atoms. Maharishi Kannad has given us the name Parmanu, and the same thing was named by Democritus as atoms. And guess what? The meaning of atoms in Greek is only indivisible, which shows that atoms are indivisible particles. It cannot be divided further. Now students, we have taken a brief introduction about the chapter, about the discovery of atoms. Now let us study laws of chemical combination. Okay, suppose that there are two reactants or any two substances. When there is a chemical reaction between these two substances or these two elements, they form a product. Or you can say two elements, when they react together, they form compound. Two reactants or two substances, when they combine together, they form a product. And this reaction between the reactants or elements happens or takes place by certain laws. And these laws are only laws of chemical combination. So whenever reactants react to form products or any elements react to form compounds, they do this by certain laws, in accordance with certain laws which are called laws of chemical combination. Students, here we are going to learn two main laws of chemical combination. The first one, law of conservation of mass, and the second one, law of definite proportion or constant proportion. There is a third one, that is law of multiple proportions, but don't bother. We are going to learn it in the further classes. Here we are going to learn only first two. Law of conservation of mass. Alright. It is given by Antoine Laurent Lavoisier. It states that mass can neither be created nor be destroyed in a chemical reaction. The total mass, okay, what does it mean? It just means that before a chemical reaction, the mass of reactants will always be equal to after the chemical reactions, to the product after the chemical reaction. Suppose there are two reactants. When they react together, the mass of the reactants will always be equal to mass of products after the reaction. So the mass is always equal before the reaction and after the reaction. This proves that mass can neither be created nor be destroyed in a chemical reaction. There is no change in mass. The word conservation means no change. So there is no change in mass before reaction and after reaction. The mass remains the same. So this was law of conservation of mass. Now let us move forward with second law, that is law of definite proportions or law of constant proportions. It simply states that in a chemical substance, elements are always present in definite proportion by mass. What do I mean by this? Simple. the elements in a chemical substance or in a compound or any chemical substance, the elements are always present in definite proportion or ratio. They are present in a ratio, and this ratio is on the basis of their masses. Let's take an example of water. What is the chemical symbol of water? It's H2O. So of course, obviously, it consists of two elements, which are hydrogen and oxygen. So these elements, that is hydrogen and oxygen in water, are present in a definite proportion as according to second law. So they are present in definite proportion, in a ratio on basis of their masses. And what is that ratio? That is 1:8. What it means? It means that when we decompose 9 gram of water, then 1 gram of hydrogen and 8 grams of oxygen are obtained. So this proves that the ratio between hydrogen and oxygen in water is 1:8. Let's take another example of ammonia, NH3. So of course it contains nitrogen and hydrogen. So here the ratio of nitrogen and hydrogen, these two elements, nitrogen and hydrogen, here the ratio is 14:3. 14:3. So this was law of constant proportions. So we have studied two laws of chemical combination very properly. Don't worry students, we are going to solve numericals also on basis of these laws in some other video, in the last video in sense. All the numericals we are going to study very properly. We are going to practice much. Okay, so hereby we have finished the laws. Now let us come forward to the next, that is Dalton's atomic theory. Do you know students that when these two laws were when these two laws were exposed, then many people did not believe in it. Okay, many people did not understood it. These laws needed some proofs. These laws needed some appropriate explanations, and scientists faced problems in giving appropriate explanations to these two laws. In this case, John Dalton, he helped to give explanations to all these terms very properly. Here is a brief introduction about John Dalton. You can take a look through it. So let us study John Dalton's atomic theory. He gave some theory, and based on this theory only, we could give appropriate explanation to these two laws. So first, he gave the definition of atoms. So here the first postulate of Dalton's atomic theory: all the matter is made up of tiny particles, and these particles are only called atoms. So firstly, he only gave this definition of atoms. Then secondly, he said that atoms are indivisible particles which can neither be created nor be destroyed in a chemical reaction. So very simple. It is very simple. Okay. It is little bit similar to first law. That is, mass cannot be created nor be destroyed in a chemical reaction. So this proved, this second postulate of Dalton's atomic theory was in accordance with the first law of chemical combination. Third, he said that atoms of same element are identical in mass and chemical properties. So if one element is there, and in one element one type of atoms are there, then those atoms are identical in mass. It means that their masses are same and their chemical properties are also same. But fourth postulate says that atoms of different elements have different masses and different chemical properties. Suppose there are two elements, hydrogen and oxygen. So atoms of both hydrogen and oxygen are not identical. They have different masses as well as different chemical properties. So this shows that atoms of different elements have different masses and chemical properties. But atoms of same elements have similar. They are identical in their masses and chemical properties. Then he said the next postulate, that is atoms. These atoms combine in small ratio of whole numbers to form compounds. Yes, this proved the second law of chemical combination. That is, in a chemical substance, the elements are present in a definite proportions by mass. And this is correspondence to the Dalton's atomic, this postulate of Dalton's atomic theory. That is, atoms are present in a definite ratio of small whole numbers to form compounds, which means that atoms of elements, okay, atoms of different elements, when they come together in small ratio, then only they form one compound. Yes, you know this. When elements come together, they form a compound. And these elements, when they come together, they are present in a small ratio of whole numbers. Now, next postulate he gave, that the relative number and kind of atoms are constant in a given compound. They are constant in a given compound. So hereby, students, we have completed Dalton's atomic theory also. But students, did you know that there are some drawbacks of Dalton's atomic theory? The main drawback is that Dalton said, okay, John Dalton sir, he said that atoms are indivisible particles, or you can say atoms are smallest particle of a matter. But nowadays it is considered, or scientists say they have proved, that atoms can also be further divided into several other particles, smaller particles, which are protons, neutrons and electrons. So this is a drawback. Dalton's atomic theory, the first postulate that atoms are indivisible particles, it is wrong. It is now considered as a wrong. It is a drawback. Atoms can again be further divided also, on that is into protons, neutrons and electrons. So students, we have studied everything about John Dalton, okay, Dalton's atomic theory very properly, laws of chemical combination very precisely. In the next video, we will continue with the chapter and we will come to the main part of the chapter, that is what are atoms and what exactly are molecules. So till then, goodbye, and don't forget to like, share the video and subscribe my channel. And don't forget to press the bell icon so that you'll get the notifications very properly whenever I upload a new video. Thank you friends, and thanks for watching. Thank you.